Good morning, grade 9s, and welcome to mathematics. Today we will be looking at linear relationships and the gradient or slope of straight lines. Before we can begin with some new work, let's revise off some of our grade 8 terminology. So we looked at linear functions. A linear function is also called a straight line, and it is always a straight line. It can be drawn to look like this, going up from left to right, going vertically, horizontally, from that side to this side. Really doesn't matter as long as it is a straight line. You can connect the dots with a ruler if you need to. Okay, so if it's not linear, then it's called nonlinear. And it is not a straight line. It is curved. So if at any point in a graph you can't connect the dots with the ruler, then it is not a straight line. Okay, it is as simple as that. The next terminology is a continuous function. A continuous function is a solid line. So all the points on the graph, it can be connected. Okay, or is connected. There is no random dot somewhere or set of coordinates somewhere on the graph that is not connected. Okay, so that is a solid piece. So I've just taken this example of the straight line. So sometimes if there is a gap, if there is a hole in it, or if there is a random coordinate or there, then it's not a straight line. It's not a solid line, it is not continuous. Okay, so if it's not continuous, we call it discrete. If it's a discrete function, it's only dots on the graph, or it is intermittent. So there is an example. So what we can do, for example, is sometimes they can give you restrictions. Let's say that one and that one is included, but that one is not included, and that one is included again. Then those pieces there makes a gap in the graph. So then it is a discrete function. Also, when they tell you that and this is only natural numbers, for example. So natural numbers start at 1 there. So our first point on the graph would be there. But we can't put an arrow because it can't go to 0. So we start there. And then we say 2. But we can't connect the 2 with a solid line because natural numbers does not include the values between 1 and 2. So then it is a discrete function, and we put the dotted line there to show that this function goes on. Okay. The part that I need to emphasize here, the only way you're going to know which is when you look at your restrictions. Okay, this is something new that you haven't looked at in grade 8, so you need to pay attention to your restrictions. Okay, is it natural numbers, is it whole numbers, is it whole numbers? And that set of work that you start the year off is excruciatingly important. Okay, please go and study those so that you know the difference between natural numbers, whole numbers, integers, real numbers. Okay, very important. Go look at those. The next thing you need to know is an increasing function. An increasing function start the left is at the bottom and the right is at the top. Therefore, it looks like this. That is an increasing function. Left is at the bottom, right is at the top. If a function is not increasing, then it is decreasing. And in that case, the right is at the bottom and the left is at the top. It looks like that. Again, crucially important. You will need to know this until matric if you are planning to take maths until then. Very, very important because your formula gives you these answers. We'll look at that a little bit later. Okay, other important facts. A straight line or a linear function can always be written in the format y is equal to mx plus c. If you can't manipulate the function into that format, then it is not a linear function or straight line. Guys, very important. Manipulate does not mean change the value. Okay, you've learned this. It is expressions, so you should be able to manipulate any equation at this point to give you what you need in the format that you needed. So this is the format. You need it to look like this. You needed to start with y, then equals, then something multiplied by x plus or minus something. Okay, that is your standard format. If, however, your x or your y has an exponent that is larger than 1, it's not a straight line. Okay, so if y squared, x, y3, x3, doesn't matter. As soon as there's an exponent larger than 1, it is not a straight line. Okay, so let's look at the gradient or the slope of a straight line. Okay, this is important as you are going to use it. Okay, so we started just now and we looked at increasing and decreasing functions. An increasing function looked like that and a decreasing function looked like that. Okay, so if we just look at the graphs, they look very similar, except this one starts at the bottom, goes at the top, starts at the top, ends at the bottom. Okay, so an increasing function has a positive gradient. Okay, and a decreasing function would therefore have a negative gradient. Now you're going to tell me, but where is this? Where am I going to see if it is positive or negative? Well, the gradient is in the formula. So in the formula for a straight line, y equals mx plus c, if it is in that format, okay, then the m represents the gradient. Here in front of the x, you will have the gradient, okay. It can be positive, it can be negative, but whatever the x is being multiplied with, that is your gradient. How do we determine it? We use this formula. Vertical change divided by horizontal change. So vertical change is your y-axis. Horizontal change is your x-axis. So vertical change is the difference in y values divided by the difference in x values. And a very nice way to write that is m is equal to difference of y over the difference of x. Okay, very nice way to write it. Let's do an example of this. Okay, so here we've got a straight line on a graph. And let's just look at random points. They will always give you these coordinates. Okay, so let's say there we've got point A, there we've got point B. I know it's not to scale at the moment, but doesn't matter as long as the values are there. Okay, so let's take A and B. So there's A's values, coordinates, there's B's coordinates. So now we work with two sets of coordinates, so we need to be able to differentiate them. That is where the 1 and the 2 comes in. Okay, so for the first set of values, we call it x1 and y1. The second set, x2 and y2. Okay, so now we take that and we apply it. We want to see the vertical change over the horizontal change. So vertical change we said is the y values. So we want to see what is the change there. So we take y2 minus y1. So y2 minus y1 over x2 minus x1. So you should know how to apply that. Guys, this part you will really have until matric if you are planning to take maths until then, okay? It is literally on your formula page for matric, okay? So y2, let's see, y2 was 0. x2 was negative 5. y1 is 2 and x1 is 1. So we're going to look at the y's first. y2 is 0, y1 is 2. x2 is negative 5, x1 is 0. Substitute it into our formula, simplify it. 0 minus 2 is negative 2, negative 5 minus 0 is negative 5. Negative divided by negative is a positive. Therefore, we can see the slope is positive, the gradient is positive. Left is bottom, right is top. So our gradient is 2 over 5. Okay. Some interesting facts about gradients. You should only know this. You are going to learn to apply it in grade 10 and 11. So, interesting thing, parallel lines have the same gradient. So, if they give you two lines and they indicate that they are parallel, you can assume that their m values, their gradients are the same. And the next one is two lines are perpendicular when the product of their gradients are equal to negative 1. So if we look at these two graphs, we've got yellow and blue. It is indicated to us that they are perpendicular. So let's see. I've just made up two examples of formulas. So if we look at these two formulas, Here I have a half for m, and there I've got -2 for m. Okay, if we look at this half, we look at the blue function, it is positive, so our gradient is positive. This gradient is negative, there we can see it is negative. Okay, then take our two m values, our half times -2 will give me -1. Now we've proven that those two lines are perpendicular because their gradient is equal to -1. Okay, guys, and that sums up your mathematics for today. If there's anything you need, please comment and I will look at it for you. Have a great day, and yeah, cheers.